All right, this is our project Awake. It's supposed to detect driver sleepiness.
I need that. I really need that.
So as you know, like a lot of people drive all the time. It's the most common form of transportation in the modern world. And a lot of injuries happen due to people driving while drowsy or asleep. So if cars had a way to detect whether the person in the driving seat was, drowsy or asleep, that could prevent a lot of accidents and injuries. And that's what our product is meant to do.
So our team consisted of 6 people. We had myself, where I helped with the front end of the website and also collecting data to put towards the data set. We also had Samantha, who also helped with the front end and with the data set, and Chris, who was also helping with the front end, but he had a lot of experience in HTML, so he was able to help the most. And then we also had our backend team, which consisted of Praneeth, Santosh, and Dylan. Praneeth, he evaluated the model and improved its performance. And Santosh also trained the model and created the webcam page that you'll see later in the presentation. And Dylan also helped evaluate performance metrics and helped create the front end as well.
Hello, everyone. I'm here to talk about our journey. So when we started, we didn't have that much experience with object detection neural networks, but that's one of the benefits of this camp is that we are self-learning and we learn along the way. So regarding our tech stack, we use Python, RoboFlow, YOLO v5. We scrape data with SERP AI, and we also did manual data extraction. So the front end of our website that you see right now is built with HTML, CSS, we have Bootstrap, and we have Flask to integrate with our backend. So the backend is our model. And on the screen right now, you're going to be seeing the 6 confusion matrices, because when we first trained our model, maybe, it wasn't really that good. You can see maybe it detected like one thing pretty well, and then the others are not that good, but we made various changes. We're using YOLO v5. We cannot really touch the model directly. So a lot of the changes we implemented were through data. So we use different pre-processing methods, different augmentations, just testing with some hyperparameters. And you could just see our model is getting slowly better. And you see version 6 is the final version that's on the website. And it's very robust, very good, very accurate. And you guys will be able to see a demo of it pretty soon.
Can I ask a question?
Yeah.
So in these confusion matrices, you had like, it was an iteration over iteration, right? Of your trials.
So each time we train for about like a few hundred epochs, and then we'll have like one version of the data set. Well, each one represents like a different version of the data set. We're mainly just modifying the data, seeing what's going on, adding more data or changing like image dimensions, things like that.
So I just noticed one thing in your version 3, and I can't read the words, but the version 3 has less categories or something?
Yeah, you're gonna notice there's one less class. One thing we wanted to test out was to see if the model would be more robust if we removed the class. Clearly, that was not really the case, and we were gonna lose a core functionality of our model if we remove a class. So we brought it back and we worked out the other issues to try and make it work with 3 classes. By the time we reach version 5 and 6, it should be working pretty well with all 3 classes.
I love this. I mean, you guys had some ideas, you tested it, you had some, maybe you were guessing that this might work, tried it, and then came to your own conclusion. Yeah, this is great. This is like iterating and learning from and improving. That's great.
Now it is time for me to show you our product in action. First, I'll upload an image of a man driving his car. As you can see, our model identified him as awake. Second, I'll upload an image of another man driving his car. The model also identified him as awake. Now I'll upload an image of a man sleeping in his car. The model correctly identified him as asleep. Next, I'll upload an image of a man who is yawning while driving. As you can see, our model identified him as drowsy. And lastly, I'll upload an image of a woman who is yawning while driving. Our model identified her as drowsy. This concludes our presentation, and if you have any questions, you can ask them now.
Cool. Thank you. Applause.
So, can you all give a round of applause to Haziq's team? So very practical implementation of computer vision. Like it can be used in real time as well. And I have one question regarding the project. I'm not sure like whether it is a valid one or not, but I'll just try to ask it. So when you are training your images, or when you have your images for training, did you just have the frontal image, or you have the side as well, like the images from the side?
We had a good mix of like from the side and from the front.
Okay,